In this video, we are going to look at how to create stiff panels of cloth by welding the cloth to a carbon actor or carbon rigid. This is a very efficient way to stiffen an area of cloth and avoids running a slow simulation using a large number of iterations. So let's start with this simple example. We will turn this flat mesh into a carbon cloth and create some stiff panels in it by welding some vertices to a carbon actor. Then we will roll the ball down the cloth to evaluate the result. So let's first turn the flat mesh into a cloth, select the mesh, and then just click the cloth icon on the carbon shelf. That also generates a carbon simulation node, as one did not exist already. Now let's select some vertices and weld them to an actor. Remember, you need to select the vertices on the original Maya mesh, so unhide the input mesh and best to hide the output mesh to avoid selecting the wrong mesh. Now right click vertex, select some vertices, and then right click on the carbon shelf macro and select the actor cloth welding. Now we can do the same again to create 4 panels in total, each with its own welding setup, so we can control the welding of each panel independently. Okay, now hide the input mesh so we can just see the physics drawer of the output mesh. Also, let's hide the actor physics drawer. Then select the sphere and right click on the create rigid macro, and let's give it a whirl. So the cloth is locked in space by the actor welding, so it doesn't fall down, and the sphere rolls down the cloth as expected. You can see it's sinking in quite a bit, and we can control that in a number of ways. So there are 3 paintable attributes on the welding. There's radius, stiffness, and viscosity. The radius is in scene units and controls how far from the weld attachment point a cloth vertex can move. If you set the radius to 0, it's locked in place and nothing can move it, so you have a hard point. Let's set the first 2 panels to 0 radius and see the result. So here you can see the sphere just bounces off. Now let's set the radius to 0.5 and set the stiffness to 0, and you can see even just under the weight of the cloth it pulls the welding down. Stiffness and viscosity controls do what their name suggests, so combining these paintable attributes gives you a very powerful tool set to create stiff cloth panels without needing a large number of iterations. And for example, these panels can have hard or soft edges or any other art directed look you wish. Now let's have a look at some of the use cases. The carbon rigid cloth welding macro works just like the actor, but as its name suggests, it welds to a carbon rigid rather than a carbon actor. A carbon rigid is a dynamic object, and so it can be dragged along with the cloth, but by making its mass very low, it does not impact the cloth behavior itself, just the welding affects the cloth, and that is independent of the rigid's mass. Let's look at using a rigid welding to stiffen a fold on a skirt. Here is the avatar from a carbon tutorial. I'm going to hide the body to make it easier to see what is going on. Okay, so let's hide the physics drawer of the skirt, hide the skirt output mesh, and unhide the input mesh. Right click vertex, and let's select this fold here. Now select the rigid cloth welding macro. Next we need to make the rigid very low mass so it doesn't interfere with the sim. So let's set it to 1 gram. Now let's hide the welding rigid so we can see what's going on with the cloth. And you can see that the fold is holding its shape here as we run the sim. Let's compare that with the welding deactivated and again activated. So you can see the impact the welding's having on maintaining the stiffness of that fold. The welding here is not fully locked down and there is still some scope for movement. But if we set the radius to 0, then it truly locks the welding, and you can see it truly maintains the shape of the fold. Okay, let's look at another example. Rubber cogs. We could use pressure to pump them up, but we would lose the sharp features if we did that. So instead, here we have welded a rigid to each cog. So let's take a closer look at how we did that. It's really easy. Let's remove the welding from the bottom cog. Okay, let's run the sim, and you see it just gets squashed. So let's look at adding the rigid welding back. Let's hide the carbon physics drawer of the cog and make sure we have the input mesh selected. We want to select all the vertices of the cog, so if we're using camera based selection we need to make sure it's turned off so we get all the vertices. Right, that's all the vertices selected. Now run the macro and hide stroke unhide everything again. And boom, there we go. The red cog is getting squashed at the bottom though, because we need to reduce the rigid mass from its default 1 kilogram. So let's make it 20 grams like the other cogs. That's better behavior now. In this final example, we are using rigid welding to cloth to create a plastic look for this shoe upper simulation. We hope all this gives you some ideas of the application of cloth welding to actor and rigid, and thank you for watching.